This time we're supposed to determine the value of the signed binary number in 1's complement form. Now what we have over here? We have 0 at the front. We said that 1's complements represents the negative numbers. But if I have 0 at the front, this is positive number. And what we're supposed to do next, simply convert this binary number to decimal. So I'm going to write this number below the binary weights. So I have 1, 1, 1, 0, 1, 0, 1, and this is my 0. If I want to determine the decimal value of my binary number, I'm supposed to just add weights which are above 1's. So I have 64 plus 16 is 80, plus 4 is 84, plus 2 is 86, plus 1 is 87. So this number represents positive 87 base 10. This is the solution to my problem. Let's take a look at the next example. Again, we're supposed to convert the binary number, the signed binary number expressed in 1's complement form. Look at the leftmost bit. If the leftmost bit is 1, this is negative number. So what we're supposed to do first in order to find the decimal value of it, simply you have to find the complement of every single bit. So I have to simply, instead of 1, write 0, and instead of 0 I'm supposed to write 1. So that's why I'm going to have 3 zeros over here. 1, 0, 0. This is my binary number, and because I had 1 at the front means it was negative number. So let's find what number is it. So I have 0, 0, 1, 0, 0, 0, 1, 0. 64 plus 4 is equal 68. That's why this number in 1's complement is representing negative 68 base 10. This is the solution to my problem. Let's take a look at the next example. Again, we have the signed binary number expressed in 1's complement form. Always look at the first bit. If the first bit, leftmost bit, is 1, it means that this is negative number. So what you're supposed to do, you're supposed to simply invert every single bit of this number. You're supposed to find the complement of every single bit of this number. Simply write 0, 0, 0, 0, 1, 0, 1, 0. And next, find out the decimal value of this number. And this is going to be 0, 1, 0, 1, 0, 0, 0, 0. 8 plus 2 is equal 10. So this signed binary number expressed in 1's complement form is equivalent to the decimal negative 10. So this is the solution to my problem.